Okay, in this problem, we want to solve the differential equation 2xy y prime is equal to 4x squared plus 3y squared with initial condition y1 is equal to -1. And so there are actually a couple different methods we can use to solve this. I'm going to solve it as a homogeneous differential equation. Now, the reason I can see that is if I isolate y prime, if I divide both sides by 2xy, right, this part, then I get 4x squared plus 3y squared divided by 2xy. And if I distribute this out, I get 4x squared divided by 2xy plus 3y squared 2xy. And the first term here is going to be 2x over y. And the second term is going to be 3y over x, 3y over 2x. And so you can see here that the derivative, y prime is dependent on the ratio of y over x, or x over y. You can think of it either way. Right? I could rewrite this as 2, or here, I'll rewrite it here. Y prime is 2 divided by y over x plus 3 over 2 times y over x. So in other words, the right-hand side of this equation is a function of the ratio y over x, which means it's a homogeneous differential equation. And so with homogeneous equations, we can use the substitution. U is the ratio y over x. And so that means u times x is equal to y. And by the product rule, u prime times x plus u is equal to y prime. And so on the left-hand side here, I get u prime times x plus u. On the right-hand side, I get 2 over u plus 3 halves of u. And after we make this substitution, the resulting equation in terms of x and u should be separable. If you've seen my previous video on the general derivation of homogeneous equations, but even if you didn't see that, notice if I isolate u prime, the derivative, I get 2 over u plus, well, I get 1/2 u because of this u moved to the other side of the equation, all divided by x, which you can see is the product of a function of u, 1/2 u, product of function of u times a function of only x, right? This is a function of u, function of x, and so this equation is separable. And if I so on the left-hand side, I'll write du dx. On the right-hand side, I have 2 over u plus 1/2 u times 1 over x. Move all the u terms to the left-hand side, and the right, I'm moving all the x terms. And so I get 1 over this big fraction, 2 over u plus 1/2 u du is equal to 1 over x dx. And with this big fraction on the left, we can kind of clean things up by multiplying both numerator and denominator by 2 and also by u in order to clean up these denominators. So if I multiply numerator and denominator by 2u, I get 2u in the numerator, and then I get 4 plus u squared in the denominator. Same thing on the right-hand side, 1 over x dx. Then I can integrate both sides. And on the right-hand side, it's pretty simple. I get the natural log of the absolute value of x plus an arbitrary constant. On the left-hand side, we can use integration by substitution, because you can see the derivative of the denominator is in the numerator. And so if I use the substitution v is equal to 4 plus u squared, I'll be able to simplify that, and that will end up being the natural log of 4 plus u squared. And here we don't need the absolute values around the natural log because 4 plus u squared is always positive. And then here we want to isolate u. And so we're going to take the exponential of both sides. So on the left side, we get 4 plus u squared. And on the right side, we get e to the natural log absolute value of x plus our constant. On the right-hand side, this will become e to the natural log absolute value of x times e to the constant, which will just become, well, this will be the absolute value of x, and this will just be a constant. So I'll combine the constant in the front, multiply by absolute value of x, and I'll call my old constant c1. So that this new constant c is equal to e to the c sub 1, right? Because e to the arbitrary constant is just an arbitrary constant. And so now I have 4 plus u squared. And so u squared is equal to c, absolute value of x minus 4. And now from here, I could solve for u by taking the square root of both sides to get plus or minus. But since we're already trying to find the solution in terms of y and x, I'll plug back in. Remember, u is y over x, and so u squared is y squared over x squared. And so we get y squared over x squared is equal to c, absolute value of x minus 4. And so y squared is equal to c, I'll write it as absolute value of x times x squared minus 4x squared. You can write it like that, but I actually prefer to factor out the x squared. You'll see why in a second. Because when I take the square root of both sides, I get y is plus or minus the square root of this big thing here. And we can break this up because the square root of x squared part in the front gives us the absolute value of x. Right? Square root of x squared is the absolute value of x. So this is our general solution. We want to determine the particular solution. And so if you go back up here, we can see that our initial condition is y of 1 is equal to negative 1. So y of 1 is equal to negative 1. Now first off, notice we need to figure out if we want to use the plus sign here or the minus sign. And the way we can determine that is notice that the square root of anything is always positive, and the absolute value of anything is always positive as well, or at least non-negative, I should say. And so this whole thing is at least greater than or equal to 0. And so, in other words, the sign of y, the sign of our function y, is dependent on the plus or minus in the front. Right? If we choose a plus, then y will always be greater than or equal to 0. And if we choose a minus, then y will always be less than or equal to 0. And now since our initial condition gives us y of 1 is equal to negative 1, meaning the y value is negative 1, we're going to use the negative version of our solution. So in other words, we have y is equal to minus absolute value of x, square root of c, absolute value of x minus 4. And then if we plug in our initial condition 1 into this expression, we get negative 1 times the square root of, well, let's see here, c minus 4, right? Negative square root c minus 4 is equal to negative 1, which means square root of c minus 4 is positive 1, c minus 4 is 1, c equals to 5. And so our particular solution is y, I'll write here, y of x is equal to negative absolute value of x times the square root of 5 absolute value of x minus 4. However, remember that a solution to a differential equation, if we go all the way back up here, has to satisfy the differential equation on a specific interval, right? This function is not defined for all x, right? And it also not only has to be defined on that interval, but it has to be continuous, well, of course, and it has to be differentiable, right? Because in order to satisfy the differential equation, right, we have to take the derivative, which means it actually has to be differentiable on an interval. And also that interval has to contain the initial condition 1, right, when x is 1. And so what we can do here is first note that absolute value of x cannot be equal to 0, right, because the absolute value function is not differentiable at 0, and that means x cannot be 0. And secondly, the part inside the square root, the 5 absolute value of x minus 4, normally we would say it has to be non-negative, right, greater than or equal to 0. But also remember, square root functions are not differentiable at their endpoint, which means it can't be equal to 0. Right? If you remember, the square root function is not differentiable at that endpoint here. And so in other words, if we rearrange this, absolute value of x has to be greater than 4 over 5, which means x has to be greater than 4 over 5, or x has to be less than negative 4 over 5. Now in this case, our initial condition is x equals 1, and so we're going to choose this interval. Right? So if we choose that interval, notice that the x not equal to 0, that doesn't really matter anymore, because x greater than 4 over 5 doesn't include that anyway. And so our final interval is that this is a solution on is 4 over 5 to positive infinity. And not only that, since x is positive for all numbers in this interval, we can drop the absolute value signs. So our final answer is 5x minus 4. There we go. So this is our final answer on the interval 4 over 5 to infinity.